I'm Sarah, and this week I turned 57. Good thing it wasn't 6, 7. Anyways, um, I'd be a lot older and I'd have to hear that. But I turned 57 this week. And when I turned 57, it made me think about something related to that number. And I wanted to share it with you because the number 57 has something in common with the numbers 21, 39, 91, 51, and 1007. And that something is related to a glimpse I want to give you into Minnesota 2022 benchmark of the week, 6.3.5.4. It's a fifth grade benchmark, and I'll share that benchmark with you right now. It says that Minnesota sixth graders should be able to factor whole numbers, express whole numbers as a product of prime factors with exponents, and here's a definition for us. Identify a prime number as what? A whole number greater than 1 whose only factors are 1 and itself. So we know 1 is not a prime number. So traditionally, when I've taught prime numbers, we've looked at factor pairs and we've talked about things that are prime and things that are not prime. But I want to talk to you about how we've thought about expanding that and some tools you can use to engage students in thinking about primes. Number one, I like to go back to when they were in elementary school and look at how prime versus composite numbers were thought about and drawing out that number in an array. And if a number is prime, that array is always going to have one row or one column of those digits because the only two factors are 1 in itself. But if it's a composite number like 6, you can draw an array that's 2 of its factors, 3 dots by 2 dots. And so we have composite versus prime numbers. And thinking about arrays and the area of an array is a way of building fact fluency, but also thinking about area and geometric thinking. So it's a way of thinking about that. There's another amazing tool that I found probably 10 or more years ago, and they are these prime factor circles that you can find for free on an online manipulative site called Polypad. I've linked to it in the video below. But in that tool, all the numbers that are prime are one color. And so all of these numbers are ages that I could have been, I was in my life. And when I was these ages, well, it probably didn't start till I started teaching in my early 20s. When I turned 23, I told my students, hey, I'm in my prime. And honestly, at that time, I was in my prime. But every time I turned 29 or 31 or 37 or 41, I would tell people that, hey, I'm in my prime. And these circles can also were first found in a game that was invented by Dan Finkel, and it's a game called Prime Club. You can buy it. I'll link to it in the chat below. But there's all these beautiful patterns that emerge that students can build fact fluency in these games. In fact, some teachers, like Amy from Australia, and I linked to a vlog of hers, put up all of these numbers for students to do some notice and wonder with. And students notice the colors first, but then they start to notice that some color numbers have only one color, some have multiple colors, some have multiples of the same color. What does that mean? And you can start to unpack it and you can read more about what that would look like. And the ones that are one color, they soon learn are prime. And there's all kinds of primes. I'm not labeling them all, but there's also larger and larger primes. In fact, I'll show you what this looks like in Polypad. I'm going to give you just a glimpse at it. You can watch the longer video if you want to.
I'm going to take one. I'll take the number 18. I'll add it to the canvas here just with a click and drag. And here I can see that there are these two colors, 2 greens and an orange. And when I click on a color and I pull it apart, I'm pulling out that factor of 2. So I can see that 18 is now a 2 times 9. And I can take this green chunk and pull it out, and I see 18's prime factorization is 2 times 3 times 3. I can put them back together. If I put 2 on top of the 3, it'll find the product of those, and there 3 times 6 is 18, and I can put it back together and get 18.
So another thing that you can do with your students is talk to them about an old way of finding prime numbers. We now have GIFs that you can show them, but I really encourage you to do this with your students first, where you take all the numbers from whole numbers from 1 to 100, and you start by getting rid of all the multiples of 2. You keep 2, of course, because 2 is prime, and then you get rid of all the remaining multiples of 3, but you keep 3 because 3 is prime. Then you find the next number that hasn't been eliminated, that's 5. 5 and you say 5 is prime, there's only two factors, and then you get rid of all the factors of 5 and so on. You can see it starting over here where they name 2 as prime and then get rid of all the multiples of 2. And as soon as all the multiples of 2 are gone, you see 3 is the next available number. So you get rid of all of the factors of that because factors of that are not going to be prime, and so on and so on. So as I was thinking about my age this week, 57, I, for a moment, was like, I think I'm going to be in my prime because 57 is one of those deceiving numbers that even though I work in math, it sometimes feels like it's prime when it's not prime. In fact, there are businesses that have been called themselves, use the number 57 and called themselves prime and made that mistake. You can find cartoons, numerous of the huge numbers of them that seem like they're using prime numbers, but when you look, you're like 1 in 57, those aren't prime. And this particular comic was using those numbers to compare themselves to Deion Sanders, and he thought he was in his prime time, but I'm in my mathy prime, a little bit geeky like that. Even famous mathematicians, one of the most famous ones in our lifetime, well, he died in 2014, so a lot of you watching this lifetime, he once was presenting on something and they asked for some examples of that something, and it was prime numbers, and he gave the number 57. And even famous mathematicians can make a mistake. In fact, all these numbers that we think are prime have been given a name based on that silly mistake by a mathematician, and they're called Grothendieck numbers or Grothendieck primes. And so I'm not alone in temporarily thinking, oh, I'm going to be in my prime when I turn 57. Turns out I'm not in my prime, because if you use those prime factor circles, you can break them apart and you can see that 57 always also has factors of 3 and 19. And 19 is not necessarily a factor that people often go and see. So I want to encourage you that you let students play around with these numbers so they can see numbers they think might be prime, like 1001. Really, they can break them apart and see what factors of them and stop calling them fake primes. And there's a lot of memes out there. And you can also find numbers that you don't think are prime, but actually are, like 4,999. I feel like it should be a composite number, but in fact, it's a prime number. And so I encourage you to have students do the work, like to write out the numbers from 1 to 100, get rid of all the multiples of 2 and keep it, circle the number 3 and get rid of all the multiples of 3. You can sneak some fact fluency practice in there as you're doing it. And then investigate all the cool things about primes, because primes have a huge part of our life in the 2020s, 2025. Like, they are huge in cryptography and modern encryption. Like, when I want to get some money out of the bank and I'm using my computer to do that, primes are often involved. So do some investigation, tell your students the stories of that. And I hope this was helpful to give you a glimpse into benchmark 6.3.5.4. If you have questions or other things you want to know about this, check out and leave a comment below, but also check out the description. We left a whole bunch of resources for you to think about using with this benchmark.